Welcome to our lesson on Riemann sums. Today, we'll learn how to approximate the area under a curve using this powerful mathematical tool. Let's start with a simple example. Consider this curve y equals x squared, from x equals 0 to x equals 2. We want to find the area between the curve and the x-axis in this region. The basic idea of Riemann sums is to divide this region into rectangles and add up their areas to approximate the total area. We can form these rectangles in different ways. One way is to use the function value at the left endpoint of each subinterval. Another way is to use the right endpoint, or we could use the midpoint. Each method gives us a different approximation of the area. Let's look at the mathematical definition of a Riemann sum. For a function f on an interval, a be divided into n subintervals of equal width delta x. The Riemann sum is the sum from I equals 1 to n of f of x sub I times delta x. Here, x sub I represents our sample point in each subinterval, and delta x is the width of each rectangle. Let's calculate the left Riemann sum for our example using 4 rectangles. For f of x equals x squared from 0 to 2, with 4 equal subintervals, delta x equals 0.5. The first rectangle has height f of 0 equals 0. The second has height f of 0.5 equals 0.25. The third has height f of 1 equals 1. And the fourth has height f of 1.5 equals 2.25. Adding these areas up, we get a total of 1.75 square units. The actual area, which we can find using integration, is 8/3, or approximately 2.67 square units. We can improve our approximation by using more rectangles. As we increase the number of rectangles, our approximation gets closer and closer to the actual area. In fact, the limit of the Riemann sum as the number of rectangles approaches infinity gives us the definite integral. Riemann sums are a fundamental concept in calculus, helping us understand definite integrals and area calculations. They demonstrate how we can approximate complex areas using simple shapes, and how these approximations become more accurate as we use more rectangles.